Welcome back, everybody. This is going to be our Function Foundations from Algebra 2, Lesson 6, Inverse Functions, homework review. And so just a reminder that hopefully you watched Lesson 5, and it's tied in very closely to this lesson as well, too. So, also a reminder, if you can, please hit the like button, really help our channel out. And also, if you have not subscribed to the channel, please make sure you hit the subscribe button and turn on notifications to know when new videos are added. So, the first question we have is, if the point -7, 5 lies on the graph of y equals f of x, which of the following points must lie on the graph of its inverse? So, just to review, inverse of a function. An inverse function is a function that undoes the action of another function, kind of going backwards. A function g is the inverse of function f if whenever y equals f of x, then x equals g of y. In other words, applying f and then g is the same as doing nothing. So the idea is if you kind of do that whole composition of functions of we do pop a number into the function and then put the result to the inverse, you get back that same number. So the inverse undoes what the original function does, okay? Another way of looking at inverse is from a transformation point of view, and so to find the graph of the inverse of a function, we'll reflect the graph over the line y equals x. And the rule for transformation will be x comma y becomes y comma x, meaning if you have a coordinate x comma y type point, the inverse would just be switching the numbers, switching the place of the numbers, no. So to find the inverse over a pair, we just switch the positions of the numbers. So let's talk about how this helps us with the first question. So if the point -7, 5 lies on the lies on the graph f of x, it must be on the inverse of the inverse. Must lie on, well, we said x comma y for the inverse will become y comma x. So -7, 5 will become 5, -7. They just switch places. Therefore, the point that will be on the inverse of the graph will be choice 1, 5, -7. Question number 2, the function y equals f of x has an inverse function. We call it y equals f negative 1 of x. And if f of a is equal to negative b, then which of the following must be true? So here, we're going to see in this case that, again, we use notation f negative 1, like for the inverse, no. And so we see here that, again, if we have f of negative a, okay, equals f of a equals negative b, that means on the original function, f of a equals negative b. All right, so in the inverse, we would have negative b comma a, and what that means is the inverse, if I plug in negative b, will give me back a. So f negative 1 of b will equal to positive a, which in this case will be choice 3. Okay, so we can kind of just kind of flip the positions of the x and y, and we can rewrite them in this function form. F of negative 1 of negative b would be a. Okay, so it's kind of like switching in this case, because this now negative b becomes the input and a becomes the output for the inverse. So we mentioned that one way to look at the inverse of a function is the value switch places in the coordinate. Also, we can look at things from this point of view, that if f of x equals y, then inverse f of negative 1 of x, or so f of negative y equals x, meaning the idea of if we are kind of plugging in the output of the into our inverse to get back the original input. So f of 5 equals 7, then f of negative 1 of 7 equals 5. And the inputs and outputs switch places. So let's try a few of these. So for example, g of 1 equals negative 3. So very similar to what we did before. So g of 1 equals negative 3. That means the inverse of g of negative 3 will equal to 1. Because we have 1 comma negative 3 becomes negative 3 comma 1. See what happens is, again, when we take the inverse, we're just switching the positions in this case. So the same way for h of negative 9 equals 5, which means, sorry, h of negative 9 equals 4, negative 9 comma 4 becomes 4 comma negative 9, meaning for the inverse, if I plug the 4 into the inverse, I'll get back the result of negative 9. And in this situation, continue, that if k of blue equals green, and so again we have this idea that if you input blue, you get back out green, the inverse would be if you input green, you get back blue. So if I input green for the inverse, I'll get back blue. Okay, so this is how we can look at this for inverse, and how we can change the inputs and outputs here. So hopefully that's another helpful way of looking at this. For number 3, the graph of the function y equals g of x is shown. The value of g negative 102 is, okay, well, here's the thing. Let's, for y equals g of x, let's kind of write the table we have here of x's and y's. And so we have here it looks like in this case the x value is negative 5, the y value is 0. When the x value is negative 4, the y value is 1. When the x value is negative 1, the y value is 2. And the next last coordinate we have is it looks like when the x value is 4, the y value is 3. And I think we go one more, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think 11. If you go x value is 11, y value is going to be 4. Okay? Now, here's the thing. For the inverse, y equals the inverse g negative 1 of x, all we're going to do is switch our x's and y's. And therefore, when their x value is 0, the y value is negative 5. So here we are going to just change all of these and switch positions. When the x value, so here, negative 4 comma 1 becomes 1 comma negative 4. Negative 1 comma 2 becomes 2 comma negative 1. 4 comma 3 becomes 3 comma 4. And 11 comma 4 becomes 4 comma 11. And so therefore the value of g of negative 2, meaning when I plug in 2 into the inverse, I will get a value of 1. Therefore, g negative 1 of 2 is equal to 1. Okay? So which of the following could have an inverse that is also a function? And so we have to now kind of talk about this well too, that the idea here in this case, that if a function has an inverse that is also a function, we say that this function is 1-to-1. And we talked about that in the last lesson, 1-to-1 in this case. Okay? So, for a function to have an inverse that is also a function, it must pass both the vertical and horizontal line tests. Okay, very important idea. So we talked about one-to-one function, meaning in this case that it would be all the x values of the function are going to be unique and will have no repeating y values, and all the y values will have no repeating x values. And it kind of makes sense because you're switching x and y, that again the almost like reflecting the vertical line over the line y equals x against your horizontal line. So let's go back to our question here. Which of the following has an inverse also function? Well, these are all functions because the vertical line test works out great. But we'll see in this case when we apply the horizontal line test here. Horizontal line, nope, no good because we hit in this case 3 points. So not going to be a one-to-one function. And then here for this one, we hit 2 points. So this will not be a one-to-one function. And actually the first one, if we draw a horizontal line, we will not get 2 points, so the inverse will not be a function. Therefore, in this case, we draw a horizontal line anywhere for number 4. We're only hitting this graph once. Oops, that's not horizontal. Yeah, there you go. So we see in this case that the choice 4 will be the one that has inverse is also a function. Okay. All right. And so, if a function has inverse, that's also a function. We say the function is one-to-one. For a function of inverse, that's also a function. It must pass both the vertical and horizontal line tests. Very important indeed. Okay, so we're going to end part 1 of our homework review with this information. And I want you guys to hopefully catch part 2 as we continue with inverse functions. Please leave any questions or comments and feedback in the comment section below. And again, you know, if you have any suggestions we want to do, please ask, all right? And if there's any part of the video that you want to just kind of follow up on, no worries, let us know. And we'll definitely try to make sure that's helpful for you. All right, ladies and gentlemen, look forward to seeing you guys in the next video, okay? Make sure you catch part 2. Thanks so much for watching. Take care. Be safe.